programs are known as rectifying inspection plans, where we rectify the lot quality, where we improve the lot quality. Because the inspection activity affects the final quality of the outgoing product. Because it is affecting the final quality of the product which we are ultimately getting, hence it is called as the rectifying inspection plan. Now this is illustrated in the above figure. Now if you have observed, we are not using the word lot here, we are using lots. So usually requires corrective action when the lots are rejected, right? Here also rejected lots. Everywhere we are using lots. Why are we using lots? Till now we have been studying कि okay, we are getting a lot, we are taking a sample and we are doing the lot disposition. But why lots here? Because we'll be getting many lots. And this rectifying inspection plan we are going to study in terms of different lots. So see in this figure, incoming lots, fraction defective P0. So there are many lots which we are taking or which we are inspecting, and all these lots, they are having fraction defective, that means the proportion defective, that means the number of defectives in the lot divided by total number of items in the lot. Fraction defective is proportion defective, which is also known as lot quality. How many defective items are there in the lot is nothing but divided by the total number of items in the lot. So if a lot, for example or for instance, is of size 1000 and there are 100 defective items in that lot, then the fraction defective will become 100 upon 1000. The total number of defectives divided by the total size of the lot is called as the fraction defective of that lot, or lot quality, or proportion defective of that lot. Clear? Okay. Now so these are incoming lots. There are many such lots which we are going to inspect. So in example where we had discussed the example of packaged fruits or packaged juices, so the product was fruits, right? So we can have a lot of apples, another lot will be of oranges, another lot will be of grapes, another lot will be of watermelon. So there are many incoming lots, right? The fraction defective of those lots is P0. Now this is the inspection activity, right? This is where we are applying the acceptance sampling plan. We are taking a sample from each lot, then we are either rejecting the lot or we are accepting the lot. This is where rectification is happening. Now the rejected lot, again here in rejected lot we are doing 100% inspection. This is what we have seen. If the lot is rejected, we are doing 100% inspection. After doing 100% inspection of that lot, now that lot has no defective items, because either we are removing the defective items or we are replacing them with good items. So there are no defective items. In the accepted lots, however, the fraction defective will be P0 only. Because the lot is accepted, we are not doing 100% inspection. We are not replacing the defective items with good items. No, we are not doing anything. We are just simply accepting the lot. So from all these lots, some lots will be rejected. After rejection, after doing 100% inspection and replacing or removing the defective items, will be getting ultimately 0 fraction defective. In accepted lots, because the lots are accepted, we are not doing 100% inspection, we are not carrying out the inspection activity, and hence the fraction defective will be P0. And hence the average fraction defective will be average of 0 and P0. Suppose that is P1. So these are the outgoing lots, and the fraction defective of these outgoing lots will be average of 0 and P0, which is P1, and it will be definitely less than P0, right? Because it is average of P0. Fraction defective of the lots which are accepted is P0. Fraction defective of all those lots which are accepted is 0. That means the number of defectives in the outgoing lots has been reduced because of this process. So average of 0 and P0 is P1, which is less than P0. So here we have rectified or improved the quality of the outgoing lot. and hence it is called as rectifying inspection plan. Suppose that the incoming lots that are submitted for acceptance inspection have fraction defective P0. So suppose the incoming lots, right, we have already discussed, we'll just read it out once. Suppose that inspection lots that are submitted for acceptance inspection have fraction defective P0. So P0 is the lot quality of the lots which are incoming, which we are going to inspect and apply this acceptance inspection. Suppose of the lots will be accepted, some of the lots will be accepted and some will be rejected. The rejected lots will be screened and 100% inspected, and their final defective will be 0, because we are 100% inspecting, and either we are removing the defective items or we are replacing the defective items with non-defective items. Ultimately, the rejected lots after screening or 100% inspection, they'll be having 0 number of defective and their fraction defective will be 0. However, accepted lots, they have fraction defective P0. Just note these lots here. We are talking about lots, not lot. So accepted lots have fraction defective P0. Consequently, the outgoing lots from the inspection activity are a mixture of lots with proportion defective P0 and proportion defective 0. So the average fraction defective in the outgoing lots is P1, which is less than P0, and this rectifying inspection program serves to correct the lot quality. Right, so I have explained this before. Let's move on. Let's see what is average outgoing quality, which is AOQ. Now, after knowing what is rectifying inspection plan and on reading this term average outgoing quality, you can now guess what this term could mean. Average outgoing quality. Let us see what it means. And if you have guessed what it means, then you are right. It is widely used for the evaluation of a rectifying sampling plan. So for a rectifying sampling plan, it is used as a measure of evaluation. That means if there are 2 plans, then average outgoing quality, this term or this number will help us to know which rectifying sampling plan is good. So the quality, average quality of a rectifying sampling plan whose average quality, outgoing quality is better, will be a better plan. So it is basically used for evaluation of a rectifying sampling plan. AOQ is the quality in the lot that results from the application of a rectifying inspection plan. AOQ is the quality in the lot that results from the application of a rectifying inspection plan. After the application of this rectifying inspection plan, the average quality of the lot which we are getting on the application of this plan is called as the average outgoing quality of that lot. It is the average value of the lot quality that will be obtained over a long period of time from the sequence of lot from a process with fraction defective P. So suppose we are having a lot of fraction defective P. Now this lot, and we'll be having many such lots of this fraction defective, right? And over a period of time, we'll be inspecting these lots. So imagine that there is a what can we say, there is a inflow of so many lots, and over a period of time lots are coming, we are inspecting, we are applying this rectifying inspection plan, and then after a long process, after a long period of time, we are now finding out the average outgoing quality of all these lots. So we are averaging the quality or the proportion defective of all these lots, and that average proportion defective will be the average outgoing quality. So it is the average value of the lot quality or average value of the fraction defective or average value of the proportion defective that will be obtained over a long period of time from the sequence of lot from a process with fraction defective P. And minus n. These are the number of defective items if the lot is accepted. No defective is a lot if the lot is rejected. So if the lot is rejected, no number of defective items. If the lot is accepted, then we need to find out the expected number of defective units will be PA, which is the probability of accepting the lot, because if rejected, then no defective items. So if accepted, then PA is the probability of accepting the lot. So PA into the number of defectives which we had seen will be the expected number of units which we are expecting to be there in the lot if the lot is accepted. So because P into n minus n is the number of defectives when the lot is accepted, then that is why we are multiplying this with PA, which is the probability of accepting the lot. Now these are the number of defectives, but we want average outgoing quality, and by average outgoing quality we mean average outgoing proportion of defectives. So we are dividing this number with capital N, and so these are the expected number of defectives. This is the total lot size. So this is the average outgoing quality or average outgoing fraction defective which we are expecting. So if the lot size capital N is very large relative to small n, then the formula for average outgoing quality reduces to AOQ equal to PAP approximately. So this n minus n upon n becomes 1 if capital N, that is lot size, is much greater than sample size. So n minus n upon n will become 1 minus n minus capital N, and if this sample is way too small with respect to capital N, then n minus 1 will be approximately 0 and 1 minus 0 will be 1. So this will become 1, this quantity n minus n upon n, and the average outgoing quality will be PAP approximately.